we're going to find the zeros of a fourth degree polynomial. And I want to start by noting that it appears there is a typo in this example. And it's here where I noticed a minus 32 and a minus 12. And I believe that should be a minus 32x. So we're going to proceed with solving it as if that is a 32x. So problems like these can get really long because notice that I've listed all the factors of p, q, as well as p over q. And we see that we don't really know where to start as far as an educated guess goes to who I want to try first in the synthetic division. So you can see I'm going to try a -2 first. That is one of my factors. And in theory, we would have to try as many possible scenarios until we get a root, a 0. But I'm going to go ahead and use one that I know works just to get the ball rolling and save some time. So I know -2 is going to work. And if I didn't, I'd be lucky if I tried it and it did. So I bring down the 2. And I get that I have a -2 times 2 is -4. 3 minus 4 is -1. -2 times -1 is a positive 2. This is going to give me a minus 13. -2 times -13 is going to give me a positive 26. 32 minus, or -32 plus 26 is going to give me a -6. -6 times -2 gives me a positive 12, which allows me to get the 0 that I need. So it works, and it allows us to say that -2 is a root. So we've got -2 is a 0. So how would we then proceed? Well, we have to keep going because what we have here is, and let me add a blank page so we've got more room, is we found that x plus 2 times, remember we're going to use these values from synthetic, so we've got a 2, a -1, a minus 13, so a 2x cubed, a minus x squared, minus 13x, and then I believe it was a minus 6, is what we have factored our fourth degree polynomial down to, is the product of these two. So I need to perform the synthetic division again. So I want to perform the synthetic division, and I want to do it now using the numbers of my third degree polynomial. So a 2, a -1, a minus 13, and a minus 6. Now, again, what would we use? We still have those giant list of factors. We've got so many to choose from. Well, again, for the sake of time and for the sake of practice, I'm going to use -2 again. I just want to see if it works. So I'm going to use -2 again. Maybe I know something, right? And I've got -2 times 2 is a -4, which gives me -5. -2 times -5 is a positive 10. -13 plus 10 gives me a -3. -2 and -3 gives me a positive 6. And we know this gives us 0, and we're happy. We like it. So what this means is that -2 has worked twice. So I could think of it as having x plus 2, and then these numbers would give me my second degree polynomial, 2x squared minus 5x minus 3. Now, we can work with this second degree polynomial. We can just factor that down. What I'm going to do is I use this diamond method. So 2 times -3 is a -6. And I need two numbers that multiply to give me -6 and add to give me -5. How about -6, +1? That will work. So this will now factor into 2x squared minus 6x plus x minus 3. I've rewritten the 5x as a minus 6x plus x. And now I have to do what's called factor by grouping. So in group 1, what's common is a 2x. I'm left with x minus 3. Bring down the sign. What's common in x minus 3 is just a 1. So I'm left with an x minus 3. We see that these match, so we know we factored correctly, and we now have 2x plus 1 times x minus 3. But we can't forget that we had 2 factors of x plus 2. So our 4th degree polynomial that we started with has now been factored completely. And we see that we have x plus 2 squared because we have 2 factors of it. We have a 2x plus 1 and an x minus 3. So if we were to find the zeros and their multiplicities, as we set out to do, we know that this, setting them all equal to 0, this x plus 2 would give me x equals negative 2, because we set x plus 2 equal to 0 and solve. And note that the square doesn't change it at all. If you set x plus 2 all squared equal to 0 and solve, you're still going to get x equals negative 2. This 2x plus 1 equal to 0 would give me that x equals a negative 1/2. You would subtract 1 and divide by 2. And this is going to give me that x equals 3. So now we have found all zeros. Here they are. What are their multiplicities? Well, it looks like each of these, the x equals negative 1/2 and the x equals 3, both have multiplicity 1. However, our factor of x equals, our 0 of x equals negative 2, this has multiplicity 2. And that's because x plus 2 had 2 factors and it was to the 2nd power. We'll see soon how multiplicity plays a role in our zeros when we begin graphing.